Let's read this question. Okay, a boat moves relative to water with a velocity which is n is equals to 2 times the river velocity or river flow velocity. Achha. So suppose there is a river. Okay, let the velocity of river be v. Okay, now there is a boat out here. Okay, the capacity of boat is 2 times less than the river flow velocity. That means if velocity of river is v, the capacity of engine of boat is nothing but v by 2. Okay, now what is the question asking? The question is asking at what angle to the stream direction must be the boat to minimize drifting. Acha, okay. See, the capacity of engine of the boat is v by 2. So what the question is asking is, this boat was not out here. This boat was at this bottom. Okay. Now the boat has to travel, no? And boats have to travel on the opposite shore. Okay. And while traveling to the opposite shore, the river current will travel in this direction. So suppose while going to the opposite shore, he reached out here. Okay, he reached out here. So this much amount is called drift. This much distance is called drift, and this must be minimized. So what should be the angle, okay, along the stream direction? So suppose what should be the angle along the stream direction so that drift is minimized. Okay, now see out here. Even if the boat, okay, boat, see, even if the boat out here travels with its full capacity v by 2 in this direction, and the direction of river is this side. So even at this extreme condition, what will happen is the boat cannot minimize drifting because the river velocity is much higher than the capacity of the boat. But what will happen now is that for eternity it will move in horizontal direction. It will never cross only. Understood? So it will never cross, and eternity it will drift it in the right hand direction with velocity v by 2, because the net velocity is v minus v by 2, which is equals to v by 2 in right direction. So for eternity it will move along right without crossing the river. Now say another condition. Boat. If all the capacity of the boat is kept along this direction, okay, what will happen? The river, since all the velocity of the boat, since all the velocity of the boat is kept in this direction, what will happen is the boat engine will perform all the velocity in this direction, and the river current will carry him in this direction. So out here drift can get very large drift. Okay, because no velocity, no component of velocity is used to counteract this drift. Okay, very large drift. Now the question is, what should be the angle of this v by 2 velocity or capacity of the engine of the boat? What should be this angle theta, so that this distance or this drift is minimum? See out here. So the theta must be balanced in such a way that the time taken to cross the river is balanced, and while time taken to cross the river is balanced, this drift is also balanced. That means this component or horizontal component of velocity should be minimum, and time should also be minimum. Okay, if we tend to keep horizontal component of velocity absolute minimum, then what happens? Time gets to maximum value. At infinity also it would never reach the opposite shore. But if we minimize the time out here, that means if we pull out full strength of the boat perpendicular to the river, then what happens? The horizontal component of velocity gets maximum value and it produces very large drift. So somewhere we must balance the time and the horizontal component of velocity. Okay, so I get the intuition that we must have a differentiation, or we must do some differentiation out here. But differentiation of what? So somehow we must create an equation of drift with respect to theta and differentiate that with respect to theta. Okay, so d of drift by d theta. should be equals to 0. But how do we create that equation? Okay, so see, time taken to cross that river. Suppose theta, time taken to cross the river. Time taken to cross the river. Suppose tau. Tau is nothing but distance by time, sorry, distance by speed. What is the distance? D. Let the width of the river be D. So D by, what is the speed? Speed of the boat is nothing but V by 2 sine theta. V by 2 sine theta. Now time taken to cross the boat, for time taken to cross the river by the boat is equals to same time the drift will act, no? Okay. What is the horizontal component of velocity? Horizontal component of velocity, component of velocity. What is the horizontal component of velocity? V minus V by 2 cos theta. V minus V by 2 cos theta. And what is this drift? Drift is nothing but horizontal component of velocity into time taken to cross the river. So drift is nothing but horizontal component of velocity V minus V by 2 cos theta into what is the time taken? Time taken is nothing but D into V by 2 sine theta. But drift is equals to, because drift is equals to speed into, or distance is equals to horizontal component of velocity horizontal into time taken to cross the river. Time taken to cross the river. Okay, or distance is equals to speed into time. Achha. If we simplify this one, okay, what happens when you simplify this one? So see, out here V minus V by 2 cos theta. So out here from this equation, can I cancel this V and this V? Okay, can I send this 2 to the up? Okay, so drift is equals to, can I divide this sine theta out here? Or drift is equals to 1 by sine theta. This sine theta is divided out here. 1 by sine theta is nothing but cosec theta. Cosec theta, and cos theta by cos theta by sine theta. Cos theta by sine theta is nothing but cot theta minus 1, or cot theta by 2 into 2d. Okay. See, up till now what I did was I measured the drift, okay, with respect to theta. But drift was equals to horizontal component of speed into vertical component of time. Okay. Now what this equation says is that there is a graph of drift versus theta. Okay, and the graph will look somewhat like this. I don't need to record the shape of the graph. Okay, so how do I find at what angle of theta would be minimum drift? If I differentiate d of drift by d of theta is equals to 0, can I say at whatever the equation gives us a theta, the value of theta at this, when the slope of this graph is equals to 0, the drift is minimum? Okay, so what is drift? Drift is nothing but 2d cosec theta minus d cot theta. This is nothing but the drift. What is the differentiation of drift with respect to theta? D drift by d theta is nothing but d of 2d cosec theta minus d cot theta by d theta is equals to 0. In physics, whenever maximum or minimum are asked, always differentiate and make it equals to 0. So suppose drift is minimized, you have to minimize the drift, and you have to minimize the drift with respect to theta. So somehow make a equation between drift and theta and differentiate and make it equals to 0. Even if maximum is asked, differentiate and make it equals to 0. Even if minimum is asked, differentiate and make it equals to 0. Out here, there is nothing but 2d. Achha, 2d. This d is nothing but differential. Okay, cosec theta by d theta minus d into d of cot theta by d theta, which is equals to 0. Okay. So 2d cosec theta. Differentiation of cosec theta is nothing but minus cot theta into cosec theta, and this is minus. Differentiation of cot theta is nothing but minus of cosec square theta, which is equals to 0. So if we summarize this, cosec square theta minus cot theta into cosec theta is equals to 0. We can cancel out the square. You can take cosec theta common. So cosec theta minus cot theta. Achha, out here I have made a mistake. I think do t cos theta 2d. Achha, the mistake I made out here was, see, out here 2d is kept outside. See, out here 2d is not attached to this one, so I should not have taken 2d common out here. Okay, so 2d differentiation of cosec theta is nothing but minus cot theta into cosec theta. Okay, minus d into differentiation of cot theta is nothing but minus of cosec square theta. D is nothing but the width of the river, which should be equals to 0. Why? Because d drift by d theta is equals to 0. Understood? Or this d and this d can get cancelled. I can take out d common and multiply it by 0, or divide it by 0. Divide it both by right hand side and left hand side. So 2 into, or if I organize this one, cosec square theta minus 2 cot theta into cosec theta is equals to 0. If I take cosec common, or cosec theta minus 2 cot theta into cosec theta is equals to 0. So either cosec theta is equals to 0. Can cosec theta ever be equals to 0? The minimum possible value of cosec theta is nothing but 1. Okay, so I can simply say cosec theta minus 2 of cot theta can be 0. Why? Because cosec theta is equals to 0 is not possible. Okay, or cosec theta is equals to 2 cot theta. Okay, now let's solve this. What is cosec theta? 1 by sin theta. 1 by sin theta. What is cot theta? Cos theta by sin theta. So sin theta and sin theta would get cancelled, or out here 1 by 2 is equals to cos of theta. So when cos of theta is equals to 1 by 2, theta is equals to 60 degree. Okay, so if this was the river, okay, and boat, and the velocity of the boat was v by 2, okay, half of the river velocity, and velocity of the river was v. If we make this angle 60, the drift out here, there would possibly be drift. Okay, there is no way in which drift can be avoided, but drift can be minimized. Okay, if theta is kept at 60 degree. All of you understood the problem? Okay. Let's read the question. Two bodies were thrown simultaneously from the same point. One straight up and the other at an angle of 60 degree. So from the same point, two bodies are thrown. One straight up with 25 meter per second and another at the rate of 25 meter per second at an angle of how much? 60 degree. This is body A, this is body B. So the projectile of this much. Okay. Now, the initial velocity of each of the bodies is 25 meter per second, neglecting air drag. Okay. So air drag is not there. Find the distance between the bodies at t is equals to 1.7 seconds. So out here, body A, which is projected with 25 meter per second, will go straight up and come down, no? And body B, okay, the velocity of body B or projectile motion of body B can be component into two components. The vertical component is nothing but 25 sine 60 and the horizontal component is nothing but 25 cos 60. Achha. What is the relative velocity of body A with respect to B? That means when you put our observer on B, okay, with what velocity does he see the ball A? So velocity of A with respect to B is nothing but VA minus VB. Achha. What is the acceleration of ball A with respect to ball B? Acceleration of ball A with respect to ball B is nothing but, what is the acceleration of ball A? G downward. What is the acceleration of ball B? G downward. So acceleration of ball A with respect to ball B would be 0. That means there would be no acceleration of ball A with respect to ball B. That means, see, the velocity of ball A with respect to ball B would always be the velocity difference. That means what I am saying is that, what is the velocity of ball A? 25. What is the velocity of ball B? 25 sine 60. 25 sine 60 is nothing but 25 into root 3 by 2. Or velocity of ball A with respect to ball B is nothing but 1 minus 25 into 1 minus root 3 by 2. That means out here, the person at ball B will be looking at ball A moving up with direction or with velocity of 25 into 1 minus root 3 by 2 meter per second. And this relative velocity would never change. Why? Because the relative acceleration is equals to 0. Understood? Now, what is the relative velocity of A with respect to B in horizontal component? Horizontal component. Okay, this one was the vertical component. Vertical component. The horizontal component is horizontal velocity of A minus horizontal velocity of B. Horizontal velocity of A is 0. Achha. Horizontal velocity of B is nothing but how much? 25 cos 60. 25 cos 60 or is equals to minus 25. What is the value of cos 60 into 1 by 2 or minus 25 by 2 meter per second. Now the question is asking what is the distance between the two ball at 1.70 seconds meter. So at 1.70 liter, the vertical separation would be vertical component of velocity into time. The horizontal separation would be horizontal component of velocity into time. Okay. So after 1.70 seconds, vertical separation would be x vertical or vertical separation or y vertical. Let's not make it x, let's make it y vertical. Vertical separation would be vertical relative speed into time. So 25 into 1 minus root 3 by 2 into what is the time? Time is 1.70. Why? Because distance is equals to speed into time. Achha. What is the horizontal separation? Horizontal separation or x horizontal is equals to minus 25 by 2 or horizontal component of velocity into 1.70. Achha. What is the total separation? Total separation is equals to under root of y component square plus x component square or is equals to, achha, can I take 25 into 1 minus root 3 by 2 into 1.70 whole square plus minus 25 by 2 into 1.70 whole square root. So if you take 25 into 1.70 common and take it outside, so is equals to 25 into 1.70 into under root of 1 minus root 3 by 2 square, plus minus 1 by 2 square, minus 1 by 2 whole square. If you multiply this 25 into 1.70, remaining is calculation, okay, remaining is nothing but calculation is left. 1 square plus 3 by 4, okay, so 1 plus 3 by 4 plus 2ab, 2 into root 3 into 1, or minus 2 root 3 or root 3, okay, plus 1 by 4, okay, plus 3 by 4 plus 1 by 4 is nothing but 1, plus 1 is nothing but 2, okay, so it is nothing but 25 into 1.70 into 2 minus root 3, 2 minus root 3. Just calculate this on your own and find the answer. Okay, see out here. Two particles move in a uniform gravitational field with an acceleration g. Okay, at initial moment, the particles are located at one point and move out with velocity v1 and v2, 3 meter and 4 meter per second horizontally in opposite direction. Find the distance between the particles at the moment when their velocity vector becomes mutually perpendicular. So what is happening out here? The particle 1 and particle 2, okay, has velocity 4 meter per second and how much? 3 meter per second. Okay. Now this particle will fall like this and this particle will fall like this. Okay. So at certain time, suppose at certain time the velocity of the vector of the particle is somewhat like this. Okay. So v2 and the velocity vector of the first particle is v1. Okay. Find the distance between the particle, between these two particles when v1 is perpendicular to v2. When v1 is perpendicular to v2. So how do we find, or when v1 vector is perpendicular to v2 vector? So how do we find what is the condition for perpendicularity? If two vectors are perpendicular, what is the formula that we can apply? Can I say when v1 is perpendicular to v2, then dot product of them would be 0? That means v1 dot v2 is equals to 0. Why? Because cos 90 is equals to 0. So this much we know. Now see, what is the vertical component of velocity up till here? The vertical component of velocity is nothing but how much? 0. The initial vertical component of velocity is equals to 0. Initial vertical component of velocity is equals to 0. So let t be the time when this velocity becomes like this and this velocity becomes like this. Let t be the time when this velocity becomes like this and this velocity becomes like this. So the vertical distance covered in time t is same, because initial vertical component of velocity is 0. Okay. So at time t, vertical component of velocity is vertical component of velocity of both bodies vertical component of velocity of both bodies is how much? Can I apply v is equals to u plus at? Out here u is equals to 0, a is equals to g, or v is equals to gt. Okay, so at this point vertical component of velocity is nothing but gt. At this point vertical component is nothing but gt. Okay, now in projectile motion the horizontal component of velocity never changes, no? So out here horizontal component of velocity will remain 4 meter per second. Why? Because there is no horizontal component of acceleration. and this horizontal component of velocity will remain 3 meter per second. Okay, so velocity of one is minus 3i. Why minus 3i? I'm considering coordinate system. Achha, minus 3i plus gtj. Velocity of 2 is, achha, and v2 is equals to how much? v2 is equals to 4i plus gtj. Achha, out here it is minus gtj. Why? Achha, can be plus or minus. You can take downward as positive and upward as negative. Okay, it doesn't make a difference. Or let's, in this case, okay, so when v1 is perpendicular to v2, what will happen? Dot product of v1 and v2 would be equals to 0. So v1 dot v2 is nothing but, therefore v1 dot v2 is nothing but minus 3i plus gtj into 4i plus gtj is equals to 0. Achha, to multiply I dot I with j dot j, or v1 dot v2, 4 3s are 12, minus 12 plus gt whole square is equals to 0. We take this to equation. What will happen? gt whole square is equals to 12, or gt is equals to under root of 12. Okay, or t is equals to under root of 12 by g. Okay, now the question is asking find the distance between the bodies. Okay, so the distance between the bodies would be the relative velocity between, or the horizontal component of relative velocity, no, into this time taken. Understood? Why? Because the vertical relative velocity is 0. See, both the vertical velocity with respect to ground frame is gt. Okay, so the distance between them would be the horizontal component of relative velocity. So what is horizontal component of relative velocity? V relative horizontal is equals to velocity of 2 minus velocity of 1, or horizontal velocity of 2 minus horizontal velocity of 1. What is horizontal velocity of 2? 4 meter per second minus of minus 3, which is horizontal component of velocity of 1, or is equals to 7 meter per second. So therefore the separation between them would be this velocity into this time. The separation between the body would be this velocity into this time. So therefore separation is equals to, therefore separation is equals to velocity or relative velocity in horizontal direction into time, root 2 divided by g. Okay, where g is usually taken as 10, or is equals to 7 into root 12 by 10. Just calculate this and write down the answer. Let's read the question. 3 points are located at the vertices of an equilateral triangle whose side is equals to a. So out here, this is an equilateral triangle. Equilateral triangle means all the sides are same and all the angles are same. So this angle is 60, this angle is 60, and this angle is 60, and every sides are same. A, and A. Okay, now see, 3 points are located out here. Point number A, point number B, and point number C. Okay, they all start moving simultaneously with velocity v, acha, towards each other. So what happens is A starts moving towards B with velocity v, B starts moving with velocity c towards C with velocity v, and C starts moving with velocity V towards A. So after a certain while, what will happen is out here. This was a triangle, okay, each of side A. So if all of them starts to move towards each other, so after a while, A will reach out here, B will reach out here, and C started from here and will reach out here. Okay, so this is for time dt. Okay, so suppose everyone is traveling with velocity v. So after time dt, v dt, v dt, and this one is vtt. The distance out here is vdt. Now see what is happening. Now what will happen is this one was A, this one was B, and this one was C. Now see, B will start, or B will change the direction towards C, no? So B will start moving towards C, okay, with velocity v. C will start moving towards A on new direction of A. So C will start moving towards new direction A with velocity v, and A will start moving towards B with new direction or new velocity. Sorry, the same velocity v. So what will happen is they'll continuously change the velocity until all of them meet. Okay, and all of them are moving with velocity v, no? So they'll meet somewhere at the center, and where will they meet? They'll meet at the centroid at the triangle. Okay, so the point of meeting is equals to centroid of this triangle, or point of meeting of the three particles, of all the particles will occur at the centroid of the triangle, at the centroid of the triangle. Why? Because the separation between all the particles are same, and all the particles are moving with same velocity. Okay, so whenever they meet inside the triangle, all of them will have moved equal distance, okay, with equal velocity. So the most logical conclusion is all of them will meet at the centroid of the triangle, which is equal distance from all of the three vertices, because centroid of the triangle is only one point inside, which is equal distance from all the three vertices. Okay, now see, how soon will the point converge? Okay, see, now let's draw this triangle again of side A and side A. All of them are 60 degrees. Problem is, what is the distance of the vertices from, what is the distance of centroid from one of the vertices? See, if I draw, this is 90-degree angle. Okay, this angle is nothing but 30 degree. Why? Because the total angle out here is 60 degree. If the total angle out here is 60 degree, this angle is 30 degree. Achha. So let this be x. Let this distance be x. So can I say x cos 30 is equals to a by 2? X cos 30 is equals to a by 2. Why? X cos 30 is nothing but this much distance. And what is this much distance? Nothing but half of this much distance. So x cos 30 is equals to a by 2. If we simplify this one, or x into root 3 by 2, cos 30 is nothing but root 3 by 2 is equals to a by 2. A and B will get cancelled, or x is equals to a by root 3. So this distance, x is nothing but a by root 3. Achha. What is the component of velocity? Achha. V was moving in this direction, no? Achha. What is the component of velocity towards this one? So component of velocity towards the centroid is equals to v cos 30. V cos 30. Okay, or is equals to v into root 3 by root 3. Now the third question is, how soon will the point converge? See, the time taken for this particle to move out here is equals to time taken for this particle to move out here is equals to time taken by this particle to move out here. So can I simply say displacement, or displacement is equals to velocity into time. S is equals to ut plus half at square, and acceleration is 0, so S is equals to ut, where u is nothing but v cos 30 or v root 3 by 2. Let's write it neatly out here. S is equals to ut, u is nothing but v root 3 by 2, and S is nothing but a by root 3. So S, which is equals to a by root 3, which is equals to u. U is nothing but v root 3 by 2 into t. If we find out the value of time, the value of time is nothing but 2a by 3v is equals to t, or time is equals to 2a by 3v. All of you understood this one?
Okay. See the question. Point A moves uniformly with velocity v so that the velocity vector v is continuously aimed at point B, which in turn moves rectilinearly with and uniformly with velocity u, which is lesser than velocity v. So what is the question trying to say? The question is trying to say that there are 2 points, point A and point B. Okay, point A moves towards point B with velocity v, and point B moves rectilinearly. That means in a straight line. Okay, which is perpendicular to you. See, at initial moments, the velocity v is perpendicular to you and the points are separated by it. That means this velocity v or this velocity u, okay, is perpendicular to v. Okay, and they're separated by distance L. That means L is the distance of separation between point A and B. Okay. How soon will the point converge? That means what is the question trying to say is, as the velocity, as this particle B moves in this direction, the particle A will chase this particle B, okay, and will move in this kind of path until they'll meet. Okay, so suppose the point of meeting is around here. Okay, that means the path traced by this particle is somewhere around like this, or path followed by particle A is somewhere like this, and the path followed by particle B is somewhat like this. This much is clear. Now let us say the time taken by both the particle to meet is t. Time taken by both the particle to meet is t. Okay. Now see. So what is common between them? The common thing between them is the time taken. That means the time taken for B to move from head to head is the time taken for V to move from head to head. So let's write that in equation. Okay. Now one more thing. This particle A is continuously pointing its direction at particle B. So when the particle B was out here, suppose at some midpoint, particle B was out here and particle A was out here. That means the velocity vector of A should be pointing towards B. Understood this one? Okay, this is B and this is E. Okay, okay. So in this manner, what is the equation that I can write? See, if I draw a line out here and make an angle theta, okay, let's make it neat. This angle is theta, okay, and this velocity is V. See, as the particle starts from here, the value of theta is equals to 90 out here. See, V is in this direction, theta is the angle from the horizontal. Theta is equals to 90 out here. And as this particle V meets the particle B, okay, or meets the particle B with velocity u, what is the value of theta? The value of theta is nothing but 0 out here. Okay, so out here cos theta is a variable. Okay, so can I say the time taken by this particle or the horizontal distance traveled by this particle A is equals to horizontal distance traveled by this particle B? So horizontal distance traveled by particle B, traveled by particle B. What is the horizontal distance traveled by particle B? Is nothing but speed is equals to distance into time. Sorry, speed is equals to distance divided by time, or distance is equals to speed into time. X is equals to ut plus half at square. Acceleration in x direction is equals to 0. So distance is equals to nothing but u into t. But t is the time taken, is equals to ut. Similarly, horizontal distance traveled by particle A, particle, this is particle B, this is particle A, is equals to v cos theta. V cos theta, that means v cos theta is the velocity in this direction, is equals to v cos theta. Okay, I could directly write into t, but notice one thing, this cos theta is variable out here. That means I have to take the elemental time. That means the distance covered by v cos theta velocity is nothing but for dt, and I have to integrate that dt. Understood what I'm trying to do out here? Why dt? Because the cos theta out here is not constant. The cos theta out here is variable. That's why you have to integrate this v cos theta into dt from 0 to t. Understood this one? Okay, that means the distance travel for this entire thing, or dt time, is nothing but velocity v cos theta. Okay, so can I say the horizontal distance traveled by b is equals to horizontal distance traveled by a? So from these two equations, from 2 and 3, I can easily say that ut is equals to v cos theta dt from 0 to t. Now the v out here is constant. Why? Because this particle is always chasing with constant velocity. So can I take the v outside, or ut by v, I'm taking the v on the left hand side, is equals to 0 to t cos theta dt. So this is our equation number 1 that we must remember out here. Equation number 1. Okay. Now one more thing. What is the vertical distance traveled by A and B? Okay. Can I say the vertical component of velocity? So if I draw a line out here, if I draw a straight line out here, okay, let's make this straight line with blue lines. Okay. Okay. If I draw a straight line out here, okay, can I say that the component of view along this direction? What is the component of view along this line? Component of view along a line connecting A and B. Okay, there is nothing but u cos theta. Okay, then what I'm trying to do is trying to find out the relative velocity of u, okay, with respect to A along this line. Okay, relative velocity of u with respect to A along this line. So relative velocity of u with respect to A along line AB is nothing but u cos theta minus v, u cos theta minus v, where v is the direction in this velocity. Okay, Now can I say that this relative velocity or this relative velocity, okay, v relative along AB is nothing equals to, or v relative is equals to dl by dt. And how is that possible? See, in few earlier or few questions earlier, have I noticed that problem that a particle will only meet when their relative velocity vector is collinear with relative position vector, or the relative velocity vector is 180-degree angle with displacement vector, okay, relative displacement vector. So if I take the position out here, okay, what is the relative position vector? The relative position vector is nothing but along this line, okay. The relative velocity vector should also be along this line. So when the particle is out here and the particle is out here, what is the relative position vector? The relative position vector is along this line, okay. So the relative position or relative velocity vector should also be along this line, okay. So when the particle moves from here to here, the vertical distance covered is equals to L, okay. So V relative is nothing but dl by dt, or time taken to cover the entire, or the rate of which this vertical distance is being changed. Understood? Okay. Now from this one, can I substitute this value? Can I substitute this value out here? Of course, because rate of change is equals to rate of change of vertical distance or vertical displacement is equals to u cos theta minus b. Okay. Now let's take this equation to the next page. I'm taking this equation and this equation, okay, to the next page. So these are the two equations we'll be dealing with right now. Okay, this is equation number 1 and this is equation number 2. Okay. So from equation number 2, okay, taking this much, dl is equals to u cos theta minus b into dt. If I expand this dl, okay, from 0 to L, where L is the vertical distance, is equals to u cos theta dt minus v dt, okay, from 0 to t, from 0 to t. See out here, u and v are constant out here, and integration of dl from 0 to L is nothing but the vertical distance. See the diagram. So L should be equals to u into 0 to t cos theta dt minus v. Integration of dt from 0 to t is nothing but t, because if I take the v outside, integration of 0 to t dt is nothing but t. This is from mathematics, okay. Or L is equals to u. Asha. Now check this diagram out here, or check this equation out here, okay. Can I say cos theta dt is equals to ut by v? This is from equation number 1. Okay. So cos theta dt is nothing but ut by v into ut by v. I substitute the equation from this value out here. See, integration of cos theta into dt is nothing but ut by v. Integration of cos theta into dt is nothing but ut by v. So I directly substituted this value out here instead of this one. Okay. Minus of v, or L is equals to u square t by v minus vt, or L is equals to u square by v minus v. into t, and we're required to find out the value of time t. So if you simplify, further simplify, L by u square by v minus v is equals to t. If we simplify this equation, L by u square minus v square by v is equals to t. If you take the v to the top numerator, it will become lv by u square minus v square is equals to t. Understood this one? So our answer is lv by u square minus v square. So let's look at this question. A train of length 350 meters starts moving rectilinearly with a constant acceleration 0.03 meter per second square. So out here is a train. The length of the train is how much? 350 meters. 350 meters. It starts moving in this direction. So the initial velocity is equals to 0 and the acceleration is equals to 3 into 10 to the power minus 2, which is equals to 0.03 meter per second square. Okay. See, after some time, what happened? After some time means at t is equals to 30 seconds. That means after 30 seconds from the start of the motion, the locomotive headlight is switched on, which is event 1. So let me calculate how much distance did the train travel till 30 seconds. So can I simply say S is equals to ut plus half at square. The initial velocity is equals to 0 because the train starts moving. Okay, if the train starts moving, that means initial velocity is equals to 0. Or okay, or S is equals to half. What's the value of acceleration? 0.03. What's the value of time? The value of time is nothing but 30 square. S is equals to half into 0.03 into 30 square. 30 square is nothing but 900. Okay. So S is equals to 900 into 0.03 is nothing but 27. 27 divided by 2 is nothing but 13.5 meters. So the train traveled 13.5 meters in the first 30 seconds. So how much did it travel? The train traveled 13.5. 13.5 meters. 13.5 meters. Okay. This much is the distance traveled by the train. Okay. At this point, what happened? The headlight was switched on. This is event 1. Event 1. Okay. So the locomotive headlight is switched on. And after t is equals to 60 seconds after that event, the tail light is switched on. That means after 60 seconds from this one. Okay. So after some more time, suppose the train reached out here. Okay. The train reached out here after 60 seconds from this time. Okay. So from the start, how much is this time? How much is this length? The train from the start moved for 90 seconds, no? 60 seconds out here and 30 seconds out here. So total time is equals to 90 seconds from the start. So distance moved from the start is equals to, I apply the same formula, ut plus half at square. Out here ut is equals to 0 or s is equals to half into 0.03 into what is the distance, what is the time taken for to move from the start, is nothing but 90 square, or s is equals to half into 0.03 into 8100, or 81 into 3 is nothing but 3, h3 is at 24. 243. 243 divided by 2 is nothing but 121.5 meters. So the distance it moved from the start is 121.5 meters. Okay. So distance between these two point is 121.5 meters. Okay. Now the question is saying out here when the train reached out here. Okay. After that event, the tail light signal is switched on. That means this is event 2. That means when the train reached out here, this outhead tail light signal is switched on. This is event 2. Okay. And the question is saying find the distance between this event in the preference fixed to the train. See, a person inside the train will always move along with the train. So suppose with reference to the train, the person was out here. The distance between headlight and tail light will always be 350 meters, irrespective of the velocity of train or the acceleration of the train. In the frame of reference of someone that is inside the train, what will happen? The distance between event 1 that is switching on the headlight and event 2 that is switching on the tail light will always be 350 meters, irrespective of the velocity or acceleration of the train. So out here, from the frame of reference which to the train, this is always equals to 350 meters. Okay, and to the earth. Now the second part of the question is find the distance between event 1 and event 2 with respect to earth. So with respect to earth, distance between event 1 and event 2 is this much distance. Problem is how do I calculate this much distance? See, I know that okay, the length of the entire train. Okay, first of all, how much is this much distance? Can I say this much distance is also equals to 121.5 meters? Why? If the head travel for 121.5 meters, the tail will also travel forward by 121.5 meters. No? So this distance is also 121.5 meters. Okay, now see, I need to find out the distance between these 2 points. Okay. Now let us apply simple geometry. Can I say this much distance is nothing but 350, this entire distance minus 121.5 will give us this much distance plus 13.5. So the separation between, therefore distance between distance between event 1 event 1 and event 2 is nothing but this much distance plus this much distance. This much distance is nothing but 350 minus 121.5. So 350 minus 121.5, and this much distance is nothing but 13.5 plus 13.5. Everything is meters. If you calculate this, this would come out to be 240 meters. Okay, 240 meters. So, uh, 121.5 minus 13.5. Achha. Now the next part of the question is how and with what constant velocity relative to Earth must a certain frame travel k move for two events to occur in the same point. That means out here there is a frame of reference. Okay, that is moving with certain velocity v. Okay, what should be this velocity v of this frame of reference such that event 1 and event 2 occurred at the same place? Okay, that means for event 1 and event 2 to occur at the same place. Okay, what is the distance travel between event 1 and event 2? The distance between event 1 and event 2 is 240 meters. And what is the time between event 1 and event 2? The time between event 1 and event 2 is 60 seconds. See, 60 seconds. So the velocity must be equals to distance divided by time, or distance between the two events is nothing but 240 meters divided by time between the two events is nothing but 60 seconds, which is equals to 4 meter per second. Okay, so the frame must travel with exactly 4 meter per second so that event 1 and event 2 occur at the same place.